Hey guys, welcome back to another video lesson. This is lesson 21. In this lesson, we just have one theorem and one example. So let's go ahead and go through those. First, I'm going to read the theorem and then I'm going to explain it. Okay? In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Okay? And so this says if and only if. So like most theorems, this is a biconditional. Okay, so biconditional means that the conditional is true and its converse is true. So what this is saying is that tangent, okay, if it's tangent, then it's perpendicular, and the converse is also true. If it's perpendicular, then it's tangent. Okay, so that's a little bit confusing, but let me go ahead and explain this. Okay, so you have this circle. Okay, that's just sitting there minding its own business. Let's call it circle Q. Okay, and then you have this line. Okay, that's just traveling through space, and we're going to call it line M. Remember, sometimes you can use a lowercase letter to denote the name of a line. So line M is traveling through two-dimensional space, and it happens to intersect circle Q. Okay, and it intersects it in exactly one point. And remember that what that's called is tangent, right? So when a line or a line segment intersects a circle at exactly one point, it's called tangent, right? So line M is tangent to circle Q. So we're given that the line is tangent to the circle. Okay, so let's go ahead and draw the point where it's tangent, or the point of tangency. Okay, and we'll call that point P. So given that the blue line is tangent to the black circle, okay, line M is tangent to circle Q, okay, what can we conclude? We know that if you draw the radius, that also goes to the point of tangency. That goes from the center of the circle to the point of tangency. So in other words, segment QP, we can conclude that these two are going to be perpendicular to each other. Okay, line M is going to be perpendicular to segment QP. So given that line M is tangent, we can conclude that segment QP is perpendicular to line M. And the converse is also true. Okay, so it works the other way around. Let me explain the converse. So let's say we have a circle that's just sitting here in two-dimensional space. I'm just going to draw it right here. Okay, we have circle Q. It's sitting there in two-dimensional space and it's just minding its own business. And this line is also in two-dimensional space. We'll call it line M. Okay, and line M intersects circle Q. And where it intersects it, we're going to call this point P. Okay, and this time what we know, or what we're given, is that this is perpendicular. Okay, we're given that segment QP and line M are perpendicular. Okay, well, what can we conclude? Okay, now we can conclude that line M is indeed tangent to circle Q. Okay, so what that looks like is this. So if segment QP is perpendicular to line M, then we can conclude that line M is tangent to circle Q. Okay, and this is really the case. This is really the case that we're going to use in solving our problems. Okay, and so here's our example. Okay, so in our example, it asks us, is segment ST is it tangent to circle P? So I'm going to go ahead and redraw this and kind of explain it before we just go ahead and solve it. Okay, so we have the circle. Okay, we have circle P that's sitting there minding its own business. Okay, and now we have a line segment. Okay, not a line, but a line segment. Okay, ST. There's S, there's T. Okay, and this line segment intersects the circle. And we want to know, is this tangent? So that is this case up here where we can conclude that something is tangent. Well, how did we conclude that something is tangent? What did we need to know? We needed to know that the radius going to this point of intersection is perpendicular to this line or this line segment. So if we can establish that this is perpendicular, then we know that the line is tangent. Okay, and that's what we're going to do here. Okay, well, how can we establish whether or not this, so here is the radius that we're interested in. Okay, how can we know if segment PT is perpendicular to segment ST? Because that's really what we want to know, right? That's our question. Our question is segment PT, is it perpendicular to segment ST? If it is, then we know that the blue line is tangent. Okay. Well, how we're going to figure this out is we're going to use the oldest theorem of all. It's actually not the oldest theorem, but it seems like the oldest theorem of all. You guessed it, the Pythagorean theorem. We're going to turn this thing into a triangle. Okay. And we want to know, is this a right angle right here? Okay. Because if these two things are perpendicular, if red is perpendicular to blue, then this will indeed be a right angle. Okay? And if that's a right angle, then this is a right triangle, where this is the hypotenuse. Segment SP is the hypotenuse, right? So this is what we want to see. Is this indeed a right angle? Okay. So we're given some measurements here. We know that the radius is 12 units long. We know that segment ST is 35 units long, and we're given that segment SP is 37 units long. Okay. So we're going to use the Pythagorean theorem. Technically, it's the Pythagorean converse, but we want to see, does a squared plus b squared equal c squared? Does a squared, well, actually, technically, this would be a. Okay, remember that c is always the hypotenuse, right? So we want to know, does a squared plus b squared equal c squared? Okay, so in this case, does 12 squared plus 35 squared, does that equal 37 squared? And I'll put a question mark above the equals because we're not sure if that's true yet, right? So now when we're solving this, okay, we're just going to use our calculator. And we know that 12 squared is 144. We know that 35 squared using our calculator is 1225. And does that equal 1,369? Well, using our calculator again, or just adding, we can see that this is 1,369. And that indeed is equal to 1,369. So, have we answered the question? No. Let's go back and answer the question. Okay. So we know that this is indeed a right angle. And because it's a right angle, we can conclude that these two are perpendicular. And because those are perpendicular, we know, yes, indeed, segment ST is tangent to circle P. So let's answer the question. Yes, segment ST is tangent to circle P. Box our answer, and we're good. Hope you enjoyed this video. If you have any questions, please feel free to post your comments as public comments in Google Classroom, or you can always email your teacher. Thank you.